Thank you everyone for joining us. I'm going to talk about agentic AI and immersive digital twins for disaster risk management. So how the disaster risk management will evolve in the age of AI and immersive technologies like virtual reality and augmented reality. So I would like to start by acknowledging my research team and sponsors for our research. We have students and senior researchers, undergraduate students, and from many different levels. And we have many active projects and publications with focusing on AI, informatics, and data science as the core technology, but we are applying these novel technologies today to environmental science, disaster, public health, education, and many other engineering fields. So I would like to start with the evolution of AI research, especially over the last 30 years. So when we think about the early AI examples, from expert systems, rule-based environments, from fuzzy logic to genetic algorithms, we have seen an evolution around focusing on machine learning studies, replicating the neural networks, the neural structures. And early examples of knowledge engineering started with the natural language processing, ontologies, knowledge graphs, and in the last 10 years, we have seen significant developments in deep learning, and especially in the last probably 5 years, we have seen more and more developments in large language models, especially with the introduction of ChatGPT. We have seen a significant development in AI-based communication, reasoning, and knowledge generation. And recently, we have seen examples of multimodal agentic systems imitating the human behavior and taking action without too much human intervention. So this was an overall 25 years of our experience on AI, our team focusing on every aspect of AI, both in analysis as well as communication and knowledge generation in various aspects. But when you think about AI today, especially after the last 5 years of significant developments, we are seeing AI everywhere, from financial services to manufacturing to healthcare, to robotics and communication, automotive industries and productivity, even focusing heavily on creative science as well. And this helped us to understand the astronomy, the galaxies, all the way down to Earth, especially through remote sensing, the satellite imagery. We have seen significant developments in robotics and AI helping surgeons and patients and health caregivers. And AI coupled with the robotics also handling a lot of tasks in construction, in robotics, in healthcare. But also we are seeing significant developments in telemedicine and humanoids or metahumans representing part of that health ecosystem. And finally, we are seeing significant opportunities and developments in creative sciences as well, from arts to music, AI being part of that process. So while all these sectors are affecting, we also expect to see some significant changes in how we manage disaster risk, how we communicate, how we operationalize these capabilities and tools. So I would like to discuss today what's next with AI for disaster risk management, how the disaster risk management and communication will evolve in the age of AI. So let's look at the evolution of engineering technologies with respect to disaster management and communication, forecasting, and other aspects of disaster management, from response to recovery and awareness and planning. So for the last 30 years, we have seen significant change in the technological components in these environments, starting with analog and manual tools, how it evolved to computational and desktop level software. Still, many of the legacy and traditional engineering software are on the desktop. You just install an application, manage the models, and in most cases running in a workstation and potentially in an HPC environment, a high performance computing. And in the last probably couple of decades, we have seen more and more presence on the web-based tools, GIS tools, becoming more accessible for engineers doing their tasks. Instead of using a full-scale desktop software, you can handle most of the work on the web with web technologies becoming more powerful, more capable, we are seeing examples how we can handle some of those engineering activities on the web. And in the last probably decade, we are seeing more and more developments in immersive technologies and digital twins, using virtual reality and augmented reality devices, as well as applications. And finally, over the last decade and potentially in the last 3 years, we are seeing significant developments in large language models, AI-based reasoning, as well as autonomous systems, and coming to the agentic AI, handling human-level tasks. But starting with the web-based environments, I'm going to talk about the last probably 10 to 15 years of our research group working on from web technologies to immersive technologies to AI. So I'm going to show you this last 15 years, how the technology evolved, how the systems that we design today to support disaster risk management evolved over these 15 years. So we have been involved in many large-scale operational information systems for communicating environmental data, models, forecasts, maps, and many other critical infrastructure information. This includes some of the most comprehensive and important information systems in US, in the world, and examples include the flood information system, watershed approach information system, and we design similar systems for various different states, organizations, and agencies, including Mississippi, Missouri, South Dakota, and others. And we are focusing on not just one specific flood, but it's more like about water-related hazards, from flooding to drought to water quality. Now we are focusing on hurricanes and other different disasters. And we also design community-facing systems as well as research environments, from river morphology to prairie and living labs, well forecasting, and information systems for communities, and community outreach and communication. Those are all heavily based on web-based environments and web-based GIS. And some examples that you see today includes unique structures like river communities. We have high resolution 1 meter flood inundation maps, extensive mapping, and even geoprocessing on the client side. Some of the examples I'd like to share today involves large-scale operational environments and even large-scale operational hydrological models running entirely on the web browser, as well as in the client side. It doesn't necessarily require a server. So you don't need to run these models in a big workstation or a server-side computational environment. You can run this in your browser, in your own computer, without any internet. So the idea is to bring these advanced hydrological models to the user, that they can handle these rainfall runoff models and flood forecasting outputs. We did similar examples with the real-time flood inundation map. So you can select a location in the world and select a corresponding maybe elevation data. You can generate flood inundation maps for that location, and you can also create unique scenarios and what if scenarios for this location. You can add a levee around the river, you can elevate structures and do some mitigation activities, and you can generate these maps in seconds. The idea is to give users more powerful tools so that they can generate these maps on the fly with their personal inputs. As a floodplain manager, as a decision maker, as a support personnel, you'll be able to generate these maps and forecast instantly. And these are in the level of high-level federal flood inundation map scenario and standards. And we designed also systems for visual computing. The idea is that how can we minimize the effort for users to write or work on a hydrological study without writing a code. So we designed a visual computing system for hydrology where users can put together building blocks, similar to designing a small Lego-based environment. You can put together the building blocks for a hydrological workflow, including the data, models, analysis, communication, and maps. And you can run this workflow on the fly in the web browser without worrying about the computing, the coding, and programming of these components. And the system also supported with AI. You can talk and explain what you are trying to achieve, and you will get a nice hydrological workflow that includes the observations from sensor networks to flood forecast models, and you can generate a map based on the forecast, and you can generate a damage estimation for that map. So you can connect these kind of 4 or 5 different components in an advanced hydrological modeling environment and run this model. And our group designed hundreds of geospatial data analytics products and technologies and tools that includes serious games and damage estimation, mitigation assessment, resilience and vulnerability assessment. We are looking at various different aspects with high resolution, visual dashboards, and digital twins that you can access all the critical information to take an action, to make a decision. The idea is to improve the decision-making process for individuals, for communities, for decision makers. So this includes systems focusing on flooding and drought and water quality and many other hazards. And these systems are designed for various agencies and organizations, as well as beside the disaster-related data on flooding and drought and water quality, we're also focusing on the infrastructure, how these disasters are going to affect the agriculture and properties and infrastructure, road networks, and many other critical infrastructure are evaluated within these systems. So some of the examples include high-resolution scenario generators. So you can use our web interface to create a very realistic flood event in your own hometown, in looking at your business, looking at your office and house, and you can imitate and create a very realistic flood scene in your area that will help you to connect with the community, to understand the challenges. So the idea is to utilize the Google Street Map imagery on the street to create a flood event and accessing this 360 panoramic imagery and connecting with a potential flood event. You can see the water, the reflections, refractions, and all the other critical visual elements are in place. And you can move around in the city. You can go to the highway or infrastructure, look at we can zoom in and go under the highway, look at how the infrastructure will be impacted from this flood event. So some other examples include multi-hazard tournaments. We design serious games that includes actual flood scenarios, actual mitigation actions, where you have a limited budget, you have taking turns to apply these actions at the localized level, at the watershed level, and try to reduce the impact of flooding or other disasters in the context of a watershed. So those systems are designed for federal agencies and state agencies that they are using in real time during community events, helping people understand how the decisions are made. And similarly, we designed several serious gaming systems using actual data, actual flood scenarios, and simulations. So this example is a flood game that creates a game anywhere in the world based on the selection. So you can select your city, you can select your town, you can select your neighborhood, and create a nice game level based on that Google imagery. And this could be your house, your business, your school. So you can create a game within your community and allocate certain amount of budget for this risk reduction and see the impact. And after certain minutes, this game starts simulating a flood event and show you the consequences of a flood and show you the actions that you take, how they will affect the reduction of the risk or the damage. So this is helping people teach the conceptual understanding of flooding. It has a global applicability for entire world, and you can customize scenarios. And these are all powered with real data, real dollar amounts for those disasters and damage reduction. We design games based on Minecraft that we call like Floodcraft. It's more like a modding on Minecraft. The idea is to teach users mitigation actions in a flood scenario. You can simulate a flood event, show how it looks, and after some protection that you did for your house, for your neighborhoods. It's more like a learning through play, and it helps you to have a hands-on engagement with the flood actions. You can generate flood scenes, and also it has AI-powered non-playable characters. Excuse me. It has AI-powered non-playable characters where you can talk for hours, learn from them, and we can easily connect some technical and legal language for your community, help you understand how these mitigation decisions are made, what are the criteria, what are the standards, and you'll be able to learn about this through a nice gameplay. Let's get into the immersive technologies, right? So we can look at how people are using these immersive technologies, from virtual reality to immersive reality to augmented reality, as well as holographic systems. So our team designed hundreds of cyber tools and applications in web technologies and GIS, as well as immersive environments. So these are some of the high-level screenshots, but I'm going to go deeper into some of these selected technologies. This example here is a flood simulation sandbox. You can go anywhere in the world, select your city, zoom into the area, load a flood inundation map, and simulate the flooding in your neighborhood, and you'll be able to see the real-time fluid dynamics and how the water flows, where it goes in your neighborhood. You can simulate the weather, as well as we have some damage estimation tools. We can look at number of buildings and the flood levels and calculate the overall damage for that specific building, for the community. We also have a traffic generator and routing system, so you can see the traffic is diverted and routed to different locations after the flooding starts. You have this kind of flood event experimentation, so you can simulate a flood event, see the traffic, see the crowd, how people are reacting to this flood event. It works on desktops and it works on virtual reality devices. You can fly around the city, you can walk on the bridge as the flood happening. The idea is to create this digital twin representing a community, a city, a watershed, and trying to learn from these simulations and how it's impacting communities and help people to make better informed decisions. Another system is immersive flood virtual reality environment. The idea is to create a full-scale information system with data and sensor networks, models and forecasts and maps, all integrated to a virtual reality information system. The idea is for users to fly around the world, look at the actual sensor network data in their community, and they can look at the models and forecasts and how those correspond to flood inundation maps. You can simulate flooding similarly. You can also control the system with your voice and using controllers. You can load data, unload data, fly around the world, look at the damage estimation, the flood routing, and many other hydrological simulations. You can also connect AI and you can and query data sets and run scenario analysis. Another technology that we designed is a flood action VR. This is a full city scale flood simulator. This is an example from Philadelphia. You can fly around using drones, and you can deliver supplies to the public, the people stuck in the flooding. You can also rescue them through helicopters. The idea is to train first responders in these scenarios and help them understand the challenges of flooding. This was actually a project selected as the top technical category winner in an IBM and Samsung competition a couple of years ago. We have actually created a booth at the Samsung event, a major Samsung conference, to present our technology. Another example is a holographic system. Similar to Star Wars and Iron Man, you'll be able to create holograms on your table, walk around, interact with these flood events. You can load a city, a digital twin of a city, and look at the buildings, look at the flood maps, connect with damage estimation, mitigation assessment, and many other critical components, and you can create a very visual and immersive experience for your users. And a couple of last examples here is focusing on education. So we created AI-based educational hub where you have meta-human avatars replicating the human character and human behavior, and meta-human level instructor avatars helping teach concepts in either informatics, in data collection and management and modeling and simulations. It also integrates with the ChatGPT and other AI systems where you can ask questions and connect it to a very specific content. It could be your course, it could be a technical document. You can also use this environment for collaborative editing and collaborative activities, working on proposals and ideas. It's an educational hub that connects the users with a classroom environment, with people from all around the world, working together to learn some concepts and courses, as well as use that opportunity to collaborate. Another example is a equipment and sensor hub. The idea is to help users to learn about environmental monitoring. These are example flood sensors from my mobile center. We created an equipment room where users can learn to disassemble these sensors, learn about individual components of the environmental sensing, environmental monitoring. It also has AI-based guidance and repair visits, so it will help you to learn how to repair a broken equipment or sensor. You can use this for training students and engineers, especially for unsafe, environmental, challenging monitoring situations. If you are trying to deploy a sensor in a very hard condition, you'll be able to teach that in VR without any safety challenge. We also worked on several cinematic disaster simulations, very high quality, high resolution, and 4K textures for creating very realistic flood scenes and recording that in a video, more like a nice cinematic experience, showing the dam break or other challenges in the community, how waters are reaching to different parts, simulating the rainfall and hydrological routing and many other components, showing the challenges of a big flood event in a community with realistic data and information and visualization. You can see the trees. All these trees are actually replicated in the full scale for Coralville, Iowa. You can see the storm, the thunderstorm, and other simulations, weather simulation components. All right, let's get into the AI. For the last probably 3 years, we have seen significant developments in conversational AI, how the ChatGPT and all the other AI systems from Gemini to Meta Llama systems and many other language models affecting how we access information, how we process information, how we communicate. So a big area I can summarize how people are using today from conversational AI, from being an instructor or serving in the role of a teaching assistant, or like a knowledge expert. We also see AI used as a research assistant, helping with the research workflows, accessing data, managing data for us, as well as analyzing data in the data analytics workflows as a data scientist. And finally, we have seen AI helping with the decision support in operational roles like floodplain manager or other critical roles. So here we have some examples. Over the last 10 years, before the language models become available, before ChatGPT, OpenAI, or many other big developments, 10 years ago, we designed NLP, the natural language processing systems, accessing knowledge and data and communicating them through existing applications, through Slack, through Skype, Facebook Messenger, or other devices. So we designed an AI system to communicate flood information from observations to models to forecasts and maps and damage and other underlying data. In a voice-enabled system, you can chat for hours, text, or use your voice. And we also designed Hydro Assistant that can help you to access data, hydrological data, interpret the data, and communicate the data in various levels. We designed systems for decision support, community outreach, as well as the planning documents. planning reports, as well as community champions. So we designed virtual AI-driven community champions that can help community members connect with the challenge and issue in their community, help them understand the responsibilities, capabilities of the community, help them connect with the funding resources, and take action. So those are all AI-based communication systems connecting with the local problems, local opportunities, as well as the know-how. We also design systems around scientific computing and communication. So this is an example of HydroSuite AI. We have a suite of hydrological libraries that connects to an ecosystem which we call HydroSuite, and you'll be able to run analysis, models, and forecasts, and many other critical hydrological workflows. But the idea with the HydroSuite AI is to minimize the code writing by the user. That system can write the code itself and help you to access these advanced hydrological or environmental models and the tools without writing too much code. So most of the code writing will be handled by AI, and this will help users to access these advanced tools without too much effort. Another big example here is an autonomous research workflow agent. So as we come close to agentic AI capabilities, the idea with the agentic AI is to focus on autonomous and event-driven decision making by the AI itself without too much human intervention. So in this example, we designed a research workflow agent, autonomous agent using agentic AI that helps you to define a research question, a hypothesis that also explains the process, the tasks, and the data needs, as well as models and methods that handles that data, and then writing the report. So by talking to these AI system for autonomous research workflow development, you'll be able to carry out full research process within a matter of potentially hours and complete and write a full-scale research report, potentially a manuscript, by going back and forth and working with an AI agent. So it's more like working with a professor, working like with a research assistant, working with a postdoc. The system helps you to carry out a big portion of this autonomous process, working with you, defining these research objectives, carrying out the tasks, running the models, accessing the results, generating the graphs and tables, and then potentially generating the report and the paper and giving a full-scale research output in matter of hours. And similarly, once you have this paper, we also designed the next step, the AI-assisted peer review. So once you have this manuscript ready, you'll be able to also evaluate this manuscript from the perspective of a student evaluating the paper, a professor evaluating the paper, and finally a publisher, which is a reviewer evaluating the paper. So you'll be able to get feedback from various different levels, and you'll be able to match the journal guidelines and article guidelines for any journal, any publisher. You'll be able to get some detailed feedback, both from editorial perspective, the scientific perspective, and technical perspective, and you'll be able to prepare your paper in a good quality to reduce the time in the peer review process, reduce the time between the faculty and the researcher or student going back and forth multiple times. So you'll be able to prepare a manuscript in a good quality without too much going back and forth between multiple review process. So with that, AI could be also used in various different operations. So once you have these autonomous agentic AI agents, you'll be able to create these operational roles, providing public service from floodplain management to water quality expertise, the first responders, engineers, atmospheric scientists. All these AI systems will help you create these agents, and these agents can work with the actual human agents or engineers side by side, more like a pair programmer or pair engineer working together on solving problems. I've seen some examples. I mean, last week I heard one of the famous mathematicians talk about how the AI is helping to go after some very advanced mathematical problems and challenge unsolved problems, how AI is working with more like a peer mathematician or a scientist working with you to solve some advanced computational and hydrological challenges. So some examples of these agentic systems: we designed hydrological agents to support NOAA river forecast centers that can handle accessing data, models, and forecasts, as well as connecting them with some outputs like from flood maps to damage estimation and mitigation assessment. The idea is to create an AI agent that can interpret some multi-model outputs or data from images to videos to maps, as well as some complex mathematical equations and challenges, accessing real-time data, analyzing the data, and helping the forecasters for their daily workflows. Similarly, we designed AI agents serving in various different roles for transportation agencies, from driver assistant to winter expert, driving data expert, as well as live view expert. These agents can support the drivers and support the transportation personnel, agents and field agents, as well as agents in the office, help them to access the most important data for the transportation decisions, from weather information to winter information, as well as road conditions, any traffic incidents, accidents, or any other information could be accessed through these agents in real time. While you are driving, you don't need to use an application, you don't need to touch your phone, you just start talking to the driver assistant and ask questions about the driving conditions, winter conditions, the road conditions, and you can access traffic data, the cameras, traffic cameras on the highway. All those information are available based on a specific use case, and you'll get a detailed answer and explanation while you are driving without you touching your phone and causing any unsafe conditions. We also designed some full-scale floodplain manager. When you think about the disaster risk management, one of the critical roles today dealing with the flooding is floodplain managers. And this is a certified role that you have to go through training. You have to learn lots of flood-related concepts, access lots of data, models, and forecasts, and also learn about the technical and regulatory information for your community. It requires significant effort to train a personnel on these topics and prepare them for real-time decision making. So we designed a similar AI system that helps you to access this information in real time. This system could be used to augment the capabilities of an existing floodplain manager, but also can act like a floodplain manager where a human manager is not available. This is an expensive role. So for many small communities, they cannot afford to have a floodplain manager. Our system can help them to access information about the building permits, flood inundation maps, risk assessment, mitigation assessment, and many other critical components that could take hours for a human to calculate and prepare. Our system can prepare in seconds and show you the results and help you make better informed decisions. So as we bring all these automated agents and these agent workflows together into a virtual room, virtual environment, virtual town hall, we can also create new capabilities. And this is the decision making in the AI era. So how decisions are made, can you find 10 people, 20 people in different roles can work for you in a disaster risk assessment or decision situation. So in that mindset, in that vision, we have created a framework for facilitating this cooperation, this coordination among multiple AI agents that work together to solve a specific task. So the idea is to define various different roles, occupations, and different personality, different characters and backstories, different behavioral patterns, different domain expertise, different role interactions and communication styles, and putting these AI agents in a room, thousands of these different roles can start discussing within their own access points, their own expertise, their own domain roles, and they'll be able to create a unique opportunity. The idea is to create these AI agents and serve in a role within a unique opportunity. For example, you can create 5 different agents. One is focusing on data expertise, data management. Another one is focusing on GIS. One other one is focusing on the statistical analysis. Maybe another agent is expert in hydrology, another one is in disaster risk management. When you put together these 5-10 agents in a room and give them a problem, and they can work together and look at different aspects of this problem and solve the problem together and generate a report and help for that process. And similarly, you can create different engineering services, software companies, emergency response units, as well as many public agencies could be created through that kind of agentic workflow and give those capabilities. And as we see AI becoming more powerful and more involved in hardware, including robotics, including 3D printing, and drones, and many other critical infrastructure, we can see AI can be used in immersive response in the communities, in an immersive room where you can access the best models, best data, and make decisions with the help of AI. So AI serving in that role, giving you the best information to make a decision in an emergency room, acting like a data expert, acting like a floodplain manager, acting in various different agentic roles in that decision environment, accessing the best knowledge and data, and helping everyone to achieve their goals more effectively in that process. This includes these holographic digital twins. You can create a large-scale city and a watershed, run what-if scenarios, load data, models, and forecasts, and this will help you to create a very realistic digital twin of a flood scenario in a watershed scale. And with all this information, all the knowledge, all these AI systems, immersive environments, you can create the next generation immersive response facility, from touchscreen to projectors to holographic environments. And all these decision-making tools can help you access the knowledge and data and information in a more intuitive way, more interactive way, while you are trying to manage a crisis situation during a major hurricane or major flood event. You'll be able to access the best information, best knowledge in a very interactive and visual environment, get the help from AI, you can interact with voice, you can interact visually, and get the best information you can for those process. So I would like to close with a couple of concluding slides. One is focusing on the AI adoption stages. So thinking about AI becoming more commonplace, all these tools are available, affordable, accessible, how we see AI will be adopted in our process. So I've seen examples of situations where people are afraid of AI because of the trust issues, the bias, and the data issues, hallucinations, and stuff like that. So let's see how people are adopting AI in various different levels within different processes. So as the trust, the reliability, the safety, and transparency of AI system evolves and becomes more accessible and more powerful, we are going to see some adoption process, starting with people using AI as a helpful tool, AI serving in an assistance role that helping you to assist in a specific process. And in the second level, we see people getting insight from AI and accessing data, models, and forecasts, and many other critical information. AI is augmenting our skills, helping us better understand the process and make decisions. In the next level, we see AI systems being automating some of the components of the workflow. So this is more about giving AI a partial delegation of the responsibility of the roles in decision making, in accessing data, and other things. So you can see AI becoming more and more accessible in an automated system, that AI supporting automated tasks and activities. When we go one more level, AI becoming a collaborative partner in the process, almost like an equal partner, helping you to make decisions and helping you to run models and access information, and serving more like an equal partner, helping you to go through this process and potentially reach to a good decision and accessing the best information. And in the final stage, we are going to see a full-scale AI-based autonomy where AI controls most of the components in a process. It's an AI-driven workflow where AI handles most of the critical components and tasks and minimize the involvement of human engineers or decision makers. The idea is to give AI more capabilities to access the data, knowledge, and models, and help AI to prepare a roadmap, prepare a report on a full-scale decision. Still, we can have human oversight. We don't want AI to randomly take action, but the idea is to give AI full autonomy to get the best information available. Definitely, the trust is critical here. The safety is critical. So we also need to have safety measures for AI to be taking these steps, and we need to have full control as a human driving this change with AI. And in the next level, I would like to finalize with how we have an effective AI adoption for improving our educational workflows, research workflows, and operational work. So this also includes connecting the public, the researchers, the engineers, and decision makers in that process. So we start with AI literacy and awareness. So we want everyone to understand what is possible and what's not possible with AI. Oftentimes we have seen examples of people overestimating AI, where AI can do magic. At the same time, some people are underestimating AI, and AI cannot do something very simple. So definitely there's a big spectrum of understanding about AI. So it's important to improve the literacy and awareness around AI. What is possible with AI? What are the best available capabilities, tools, and services that we can benefit today? So the second level is adopting some AI tools in our workflows. Similar to what we are using today, we are accessing web resources, we are accessing desktop level software like Excel and MATLAB and many other capabilities from different organizations. We need to also start using AI. I think we can see today everyone in classrooms, in the industry, using AI for different roles. So the second level is adopting some AI tools. But these are off-the-shelf products and tools and services that can help you to carry out some tasks in your workflow. But if you move to one more level, we can talk about custom AI solutions. So depending on your custom workflow in your company, in your organization, in your institution, in your university, you need to start thinking about creating custom AI solutions for handling some internal activities, from education to research to operational work, that will give us a more trustable AI that is in full control by the internal agency groups, and we don't need to worry about sharing our data with the cloud or agencies, organizations. We can think about a local custom AI solution helping us in our daily workflow without worrying about the privacy or other challenges. All the data stays with us in an offline contained environment. Next level is autonomous AI agent. The idea here is to create these agents that can handle certain tasks. So you have an agent that can work on the data management, you have an agent that can work on GIS expertise, hydrological expertise, disaster expertise, regulatory and legal expertise, as well as many other domain-related skills. That will help us to create these autonomous workflow agents that can help with these tasks without too much worrying about the human intervention. And in the final stage, the idea is to create this kind of self-directed AI workflows, from accessing data all the way to generating a report, a plan, a roadmap, AI handling every internal steps. The idea is to AI based on some custom internal solutions and offline data. AI will be able to run this entire workflow, self-directed with self-targets and objectives. So we define the objective, AI using the objective to create this entire workflow process and handle entire system. So I'm gonna stop here and conclude my talk. So I'll be happy to answer any questions. You can access most of these tools and capabilities are on our website, hydrointelligence.github.io, and you'll be able to access all the publications, all the project information. Some of the GitHub repositories are available here as well, so you can access the source code of many of these projects and access some of the visualizations and maps. I'm going to stop sharing, and I'll be happy to answer any questions that you might have. Thank you very much.